Hey guys, today we're going to be working on 11.3 and this is going to be all about volume of prisms and volume of cylinders. So we're going to start with talking about what volume is. Remember, volume is just the amount of space that something holds or it encloses. So if you're thinking about maybe a water bottle, okay, so how much water can fit into this plastic bottle? Okay, that would be considered volume. And when we talk about volume, we're considering the units. Remember, units for surface area is always something squared. Here it's going to be something cubed, so cubic units, so like meters cubed or feet cubed, right? And we're just going to jump right into our formulas. So to start, it says we're going to find the volume of the prism. Prisms have a really short formula for volume. It's just the area of the base, so make sure I write that down. So area of the base times the height of the base, or of the prism. So here we've got a really nice example of a triangular prism, and we just need to plug into our formula. So we first need to find what the base is, area of the base is, and because it is a triangle, we know that triangle's formula is 1/2 base times the height. Well, if you look here, the base of the triangle is 12, the height of the triangle is 10, and then we can divide by 2. So 12 divided by 2 is 6, so we get that the base area is 60. Okay, so then we can go ahead and plug into our formula. So 60 times, and then the height of the prism is 11. So 60 times 11. So then we can just go ahead, go to your calculator, and you get 660. So our volume is 660, and in this case there's no units, so it would just be units cubed. And we'd be done. Okay, so really short depending on the shape. Just like the prisms when we did surface area, when you're finding volume, the base is going to change. So you're going to have to adjust how to find the area, or in this case, find capital B, based on what the base shape is. So triangles are really easy, rectangles and squares are easy. Remember, if it's a pentagon or a hexagon or something like that, where it's a regular polygon, we'll use that 1/2 apothem times perimeter. All right? And then let's try another example. This is an example where we've got a pentagon, and we're going to find the volume. So volume is area of the base times the height. So how do we find the area of a pentagon? Well, base is 1/2 the apothem times perimeter. So we're assuming that this is a regular polygon. Okay, they'll tell you that, or they'll mark it. We already know the apothem, it's the orange dotted line. So we could say that the area of the base is 1/2 times 3.5, and the perimeter, we just have to take 5 times 5 because there's 5 sides, so we get 25. And then it's just a matter of multiplying this all out. So 1/2 times 3.5 times 25, that's going to get us 43.75. So that's the area of the base. Okay. And then we just have to multiply that number by the height. So when I plug this into my formula, I get volume equals 43.75 times, and the height of the whole prism from one base to the other, that's that, so it'd be times 8. Okay, and when we multiply that out, this one works out nice. We get 350, and this would be units cubed. And we're done. So you still have to know the formulas, like I've told you guys in the last 2 sections. You still have to know the formulas from the last chapter. Finding area of different shapes, really, really important. But the formulas for this chapter are relatively short, and like I said, I'll give those to you. So you should be good to go as long as you can plug in the numbers into the correct places. So there's 2 examples for prisms. We're going to go ahead and talk about cylinders, and then we'll be good to go. So a cylinder, similar concept, it's still the area of the base times the height, and because cylinders are always circles, we can just state that this is pi r squared times h. So this is similar to what we've seen before. So if I have an example here where it says find the volume, here we know this 8 is the h, and here's r, so we just have to plug into our formula. So volume is equal to pi times the radius squared times the height. So we get 3 squared is 9, 9 times 8 is 72, so we get 72 pi centimeters cubed. And then of course if it says round to the nearest tenth or to the nearest hundredth, you would multiply that out, but for now we'll just leave it as an answer with pi. So really short, not a lot of work to it, you're just plugging in numbers. Same thing with this one, even though this is considered an oblique cylinder because it's tilted, the concept is still the same. It doesn't matter if it's tilted or not with volume. It wouldn't matter if I was able to like bend this around. Okay, if as long as I didn't change the amount of material, I could still fit the same amount of water. All right, so in this case, same thing. So volume is equal to pi r squared h. So our radius is 5 and the height is 15. So you'd say volume is equal to pi times 5 squared times 15. So here 5 squared is 25. So 25 times 15, we get 375 pi. And that is in centimeters cubed as well. Okay. So hopefully pretty easy. You're just plugging in numbers. I would assume that where people tend to have the most trouble is the prisms, just because you have to know the different formulas for area. But if you have those handy to study from and you have them for your assignment, you should be great to go. The only other thing I want to talk about really quick is this principle here. It basically just says that if you have two solids and as long as the heights are the same, so notice these two things, we have the same heights, and a cross section. So basically, like if I were to cut a sliver out of it, as long as those sections are the same area, doesn't matter if it's tilted or not or on its side, they'll all have the same volume. Okay, so this is a special principle that says it doesn't matter if it's oblique or if it's a regular polygon or prism. All of these things, as long as they've got the same height and same cross-section area, they're going to have the same volume. So it's really nice because unlike surface area, where there might be some slightly different numbers, these are going to be a little easier to calculate the volumes. Okay. So if you have any questions on that principle, let me know. But that's really it for this section. So two formulas, mainly prisms, cylinders, area of the base times the height. That's all you need.